Voltage regulation of an alternator. Voltage regulation of an alternator. When the alternator is loaded, the terminal voltage decreases with increase in load. When the alternator is loaded, the terminal voltage decreases with the increase in load. So terminal voltage of an alternator changes from no load to full load, or voltage regulation of an alternator is defined as it is the change in terminal voltage from no load to full load expressed as a percentage of rated terminal voltage. Okay, so voltage regulation is equal to E0 minus V by V. Percentage voltage regulation is equal to E0 minus V by V into 100. Okay, when an alternator is loaded, its terminal voltage falls from no load to full load. When load increases, its terminal voltage decreases. When load increases, its terminal voltage decreases. Its terminal voltage changes from no load to full load. Okay. When voltage regulation of an alternator is defined as it is the change in terminal voltage. Voltage regulation of an alternator is defined as the change in terminal voltage from no load to full load. The change in terminal voltage from no load to full load expressed as a percentage of rated terminal voltage. Expressed as a percentage of rated terminal voltage. That is, voltage regulation is equal to E0 minus V by V. Percentage voltage regulation is equal to E0 minus V by V into 100. Where E0 is the no load terminal voltage, and V is the full load terminal voltage. E0 is the no load terminal voltage and V is the full load terminal voltage of the alternator. Performance of an alternator can be expressed. In terms of voltage regulation. Lower the voltage regulation means better is the machine. When voltage regulation increases, if the voltage regulation is high, definitely it is a bad indication for that machine. So when a generator is loaded, its terminal voltage decreases if the load is inductive. When a alternator is loaded, its terminal voltage increases if the load is capacitive. So alternator can be defined as, voltage regulation can be defined like this. It is the fall in terminal voltage when the alternator is loaded for if the load is inductive, and it is the rise in terminal voltage. It is the rise in terminal voltage when the load is capacitive. When load increases, terminal voltage decreases if the load is inductive. Okay, when terminal voltage increases when the load is capacitive, or we can define the voltage regulation like this. It is the rise in terminal voltage, it is the fall in terminal voltage when the load is inductive, and it is rise in terminal voltage when the load is capacitive. When loading increases, terminal voltage increases if the load is capacitive. When loading increases, terminal voltage decreases if the load is inductive. Clear? When load increases, terminal voltage decreases if the load is inductive. When load increases, terminal voltage increases if the load is capacitive. Then how can we find out the voltage regulation? Voltage regulation of an alternator by EMF method or synchronous impedance method. Voltage regulation of an alternator by EMF method or synchronous impedance method. How can we find out? So by conducting the voltage regulation by EMF method or synchronous method, we need to conduct two tests on alternator. One is OC test and other is SC test. The voltage regulation of a three-phase alternator can be predetermined by conducting the open circuit test and short circuit test. The open circuit characteristics can be plotted from OC test, and short circuit characteristics can be plotted from SC test. Thus we can draw these two characteristics like this. OCC means field current versus induced EMF. Field current is on x-axis, induced EMF is on y-axis. Thus we are getting an OCC. After that we can draw the short circuit characteristics, which is a straight line through origin. Okay, then field current is on x-axis, armature current is on y-axis. Okay, so field current versus induced voltage, we are getting OCC. Field current versus short circuit current, we are getting SCC. So voltage regulation of a three-phase alternator can be predetermined by conducting the open circuit test and short circuit test. After that, from these two tests we can draw the OCC and SCC. OCC means open circuit cara, SCC means short circuit cara. The synchronous impedance can be found from OC test. After that we have to find out the synchronous impedance. How can we find out the synchronous impedance? So field current, let E1 be the open circuit voltage corresponds to a particular value of field current IF, and its value is obtained from OCC, and I1 is the short circuit current producing the rated voltage corresponding to the field current as shown in figure. So synchronous impedance is equal to open circuit voltage per phase divided by short circuit current per phase. Okay, open circuit ZS is equal to E1 by I1. ZS is equal to E1 by I1. So we are getting E1 and I1 from the graph. Okay, ZS is equal to E1 by I1. Okay, let E1 be the open circuit voltage corresponds to a particular value of field current, IF, and its value is obtained from OCC, and I1 is the short circuit current. So I1 is the short circuit current corresponds to I1 is the short circuit current producing the rated voltage corresponding to field current IF. I1 is the short circuit current, E1 is the open circuit voltage corresponds to a particular value of field current or rated field current corresponding ആയിട്ടുള്ള വോൾട്ടേജ് ആണ് E1. ആ ഫീൽഡ് കറണ്ടിന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള കറണ്ട് ആണ് I1. അപ്പോൾ I1 കിട്ടുന്നത് y ആക്സിസിൽ നിന്ന്, SC കറണ്ട് എന്നുള്ള y ആക്സിസിൽ നിന്ന്, E1 കിട്ടുന്നത് ഫസ്റ്റത്തെ y ആക്സിസിൽ നിന്ന്. അപ്പോൾ റേറ്റഡ് ഫീൽഡ് കറണ്ടിന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള വോൾട്ടേജ് ആണ് E1. പ്ലീസ് അണ്ടർസ്റ്റാൻഡ്, റേറ്റഡ് ഫീൽഡ് കറണ്ടിന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള E1 ക്യാൻ ബി ഫൗണ്ട് ഔട്ട് ഫ്രം ദ OCC ഗ്രാഫ്. ഓക്കെ, അതേ ഫീൽഡ് കറണ്ടിന് കറസ്പോണ്ടിങ് ആയിട്ട് നെക്സ്റ്റ് y ആക്സിസിൽ നിന്ന് കിട്ടുന്ന കറണ്ടാണ് I1. സോ ZS is equal to E1 by I1. റേറ്റഡ് ഫീൽഡ് കറണ്ട് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള വോൾട്ടേജ് ആണ് E1. അതേ ഫീൽഡ് കറണ്ടിന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള ഷോർട്ട് സർക്യൂട്ട് കറണ്ടാണ് I1. സോ I1 ഫ്രം സെക്കൻഡ് y ആക്സിസ് ആൻഡ് E1 ഫ്രം ഫസ്റ്റ് y ആക്സിസ്. സോ thus we are getting synchronous impedance ZS is equal to E1 by I1. Then synchronous reactance XS is equal to XS is equal to root of Z squared minus RA square. XS is equal to root of Z squared minus RA square. After determining ZS and XS, RA square means armature resistance. RA means armature resistance. We can experimentally measure the value of RA. Thus we are getting synchronous reactance XS is equal to root of Z squared minus RA square. After determining ZS and XS, phasor diagram for any load can be drawn as shown in figure. Let I be the load current lagging behind the terminal voltage V by an angle phi from the phasor diagram. So no load terminal voltage. So from the phasor diagram, from this phasor diagram, so E1 ഒന്നാമത്തെ rated field current corresponding ആയിട്ടുള്ള voltage E1, അതേ field current corresponding ആയിട്ടുള്ള short circuit current I1. Okay, then V എന്ന് പറയുന്നത് റേറ്റഡ് വോൾട്ടേജ്, അതിന് I lags V by an angle phi. V എന്ന് പറഞ്ഞാൽ V is equal to, Vയുടെ രണ്ട് കമ്പോണൻ്റ് ആണ് V cos phi and V sin phi. V cos phi means OD, V sin phi means AD. So V is equal to root of V cos phi all square plus V sin phi all square. So Vയുടെ രണ്ട് കമ്പോണൻ്റ് ആണ് V cos phi and V sin phi. Okay, അപ്പോൾ root of V cos phi all square plus V sin phi all square ആണ് V is equal to, അതായത് OA is equal to root of OD square plus AD square. OA is equal to root of OD square plus AD square. That is V is equal to root of V cos phi the whole square plus V sin phi the whole square, whereas AD is equal to V sin phi and OD is equal to V cos phi. OD is equal to V cos phi, AD is equal to V sin phi. So V is equal to root of V cos phi whole square plus V sin phi the whole square. Okay. So from this phasor diagram, E0 is the no load induced EMF and V is the terminal voltage. Voltage regulation means E0 minus V by V into 100. E0 is the no load voltage and V is the voltage at loading condition. E0 is the no load voltage and V is the voltage at loading condition. So V plus, that means OA, by considering the whole triangle OFC. Okay, so we can write OF is equal to OC square plus FC square by considering the right angle triangle OFC. So we have V എന്ന് പറഞ്ഞാൽ root of V cos phi the whole square plus V sin phi the whole square. Okay, by considering the triangle OFC, OC square plus FC square, OC square plus FC square is equal to OF square. OF square is equal to OC square plus FC square. Okay, that means OF is equal to root of OC square plus FC square. അതാണ് ഇവിടെ പറയുന്നത്. OF is equal to root of OC square plus FC square is equal to, നോക്കൂ, is equal to OC square means root of, OC means V cos phi OD plus DC. OC means OD plus DC is equal to root of V cos phi the whole square plus IRA the whole square, because AB is equal to IRA and AB is equal to CD. AB is equal to CD. Okay, so V cos phi plus IRA, V cos phi plus OC square is equal to OC square is equal to OC is equal to OD plus DC. Okay, OC is equal to OD plus DC. Now OF is equal to OC square plus FC square. OC means OD plus DC. That means OC means V cos phi plus IRA. So OC square means root of V cos phi plus IRA the whole square. V cos phi plus IRA the whole square. Clear? Once again, by considering the triangle OFC, OF square is equal to OC square plus FC square. OC is equal to OD plus DC. OC is equal to OD plus DC is equal to root of V cos phi the whole square plus V cos phi plus IRA the whole square plus FC square means BC plus BF. FC means CB plus BF or BC plus BF is equal to V sin phi plus IXS the whole square is equal to V sin phi plus IXS the whole square. So E0 is equal to V cos phi plus IRA whole square plus V sin phi plus IXS whole square. V cos phi plus IRA whole square plus V sin phi plus IXS the whole square. So OF means E0. OF means E0. So E0 is equal to root of V cos phi plus IRA whole square plus V sin phi plus IXS whole square. And percentage regulation is equal to E0 minus V by V into 100. Percentage regulation is equal to E0 minus V by V into 100. For unity power factor, cos phi is equal to 1 and sin phi is equal to 0. For unity power factor, cos phi is equal to 1 and sin phi is equal to 0. So E0 is equal to root of V plus IRA whole square plus IXS whole square, because V sin phi is equal to 0. Sin phi is equal to 0 means definitely V sin phi is equal to 0. So E0 is equal to root of V plus IRA the whole square plus IXS the whole square. For leading power factor, E0 is equal to V cos phi plus IRA whole square plus V sin phi minus IXS whole square. In the case of leading power factor, equation will be V sin phi minus IXS the whole square. Okay, so in this manner we can find out V means rated voltage. E0 can be found out in this manner. First of all, find out the value of synchronous impedance. ZS is equal to E1 by I1. Vയുടെ വാല്യൂ നമുക്കറിയാം. E0 കണ്ടുപിടിക്കാനായിട്ടുള്ള ഫോർമുല റൂട്ട് ഓഫ് V cos phi plus IRA whole square plus V sin phi plus IXS whole square. E0 is equal to root of V cos phi plus IRA whole square plus V sin phi plus IXS whole square. അതെങ്ങനെ കിട്ടിയെന്നുള്ളത് അവിടുത്തെ ഡയഗ്രാം നോക്കിക്കഴിഞ്ഞാൽ, ഫേസർ ഡയഗ്രാം നോക്കിക്കഴിഞ്ഞാൽ ക്ലിയർ ആവും. ഓക്കെ.